A logarithmic function is defined as y equals log base a of x if and only if a to the y is equal to x, provided both a and x are positive and a is not equal to 1. That means that the answer to a logarithmic function is the exponent of an exponential equation. So how would we write the following in exponential form? Log base 10 of 100 equals 2 means that 2 is the answer of the logarithmic function. It's the exponent in the exponential function. So log base 10 of 100 equals 2 is rewritten as 10 to the 2 equals 100. Likewise, log base 3 of 81 equals 4 means write your base 3 to the answer, the fourth, equals 81. Now let's work the opposite way. We have 2 to the 8th equals 256. How would we write that in logarithmic form? Log base 2 of 256 is the answer, 8, the power. 5 to the 3rd equals 125 is rewritten as log base 5 of 125 equals the exponent, which is 3. And finally, 17 to the 0 equals 1 can be written as log base 17 of 1 equals 0. Okay, let's talk about some properties of logarithms. Our first one is log base a of 1 equals what? Well, log base a of 1 is equal to 0 because a to the 0 equals 1. Anything to the 0 equals 1. Log base a of a is defined as 1 because a to the first equals a to the understood 1. And log base a of a to the x is going to be equal to x because a to the x equals itself. And lastly, if log base a of x is equal to log base a of y, what's going to happen? We have logs with like bases with an equal sign between. That means that x is going to be equal to y. All right, next let's solve some equations. First we have log base 4 of 16 equals what? So we rewrite that as 4 to what power equals 16? Well, 4 squared is 16, so x has to be 2. Log base 6 of 1 is equal to what? Means 6 to what power equals 1. So x has to be 0 because any number to 0 gives you 1. Log base 9 of 3 equals what? Translates to 9 to what power gets us 3? A little more difficult here. What do we have to do to 9 in terms of powers to get 3? Take the square root, so x equals 1/2. And finally, log base 2 of -1 is equal to what? So 2 to what power equals a -1? Can we take 2 to any power and get a -1? No, so empty set or undefined. So what if I asked you to graph y equals log base 2 of x? Well, let's start by rewriting the equation in exponential form of 2 to the y equals x. Now let's create a table of values. So when 2 to the y equals x, we're going to plug in values for y to determine what x becomes. So if we put in a -1 for y, two to the negative first power is 1/2. Plugging 0 in for y, 2 to the 0 is 1. And plugging in 1 for y, 2 to the first is 2. So as you can see, our points are plotting out here nicely. If we had put a -2 in for y, we'd be here at 1/4. And we can see that our function is asymptotic to the y-axis. And it's going to get very large as we get further out. Now this should look familiar to something you've seen previously. Recall that 2 to the x equals y is something that we've graphed before. So these two are related. They are actually reflections of each other across the line y equals x, which means that they're inverses of each other. Okay, so let's next graph y equals log base 4 of x minus 3. So don't be startled by the fact that this looks a little bit scary. This is really a family of graph for y equals log base 4 of x shifted 3 which way? Three to the right. Because it's with the x, to bring it to the other side, it would be a positive 3. So we can handle graphing log base 4 of x without too much of an issue. So when x and y are placed into our t-chart, remember that we're going to call this 4 to the y equals x. So we have values for y of -1, 0, and 1, because we're picking nice numbers so we don't have to deal with messy numbers. And when when y is -1, 4 to the negative first power means drop to the denominator and you're at 1/4. 4 to the 0, anything to the 0 power is 1. And 4 to the first is plain old 4. Now, if it would make us feel better, we could go ahead and sketch this out, but it can be confusing on the graph if you have multiple functions graphed without using different colors. So let's think about what's going to happen if we shift this to the right. When we're shifting it to the right 3, that means that we're adding 3 to every value of x. and likewise the y's are staying the same. So when we plot this out, when x is 3 1/4, y is -1. It's not going to cooperate with me. When x is 4, y is 0. And when x is 7, y is 1. So we can see that this is going to become very, very small. If y is -2, 4 to the -2 power means we're going to square 4 in the denominator 1/16. So we're becoming very, very close, asymptotic to the line, to the vertical line. My apologies on my drawing here. It's not going to cooperate. So let's switch back to this view where I don't have to fight with the pen. And as you can see, it's very asymptotic to the line x equals 3. Whereas our original parent function was shifted 3 to the left. Now, what would you suspect is going to happen with the function f of x or y equals negative log base 4 of x minus 3? So once again, we've changed our parent function. We'll reflect it over the x-axis. So the x values will stay the same, but the y values will be reflected. All right, so remember E, or Euler's number, the natural base? E is the base in the natural log, as noted by ln. So ln is the same thing as log base E, which is approximately equal to log base 2.718. So let's graph y equals the natural log of x. First, put in a format that you're more familiar with, where e to the y is equal to x. Next, let's plug in some values. So when y is 1, e we said was 2.718. When y is 0, e to the y will be 1. And then finally, when y is something like 2, let's pull out the old handy graphing calculator. And your natural log is listed on your calculator. The shift of natural log is your e to the button. So when y is 2, x will be about 7.4. And we could put one more number in here. I didn't add it to the top. When y is -1, we get 0.37. All right, so what would the function y equals a negative natural log of x minus 1 look like? Well, let's work it out. Let's add a new table here. And again, family of graph tells us that this guy is going to be shifted to the right one and reflected across the x-axis. So let's take those same values that we had for y and then think about what is going to happen with the values of x. X is now shifted 1 to the right, but then they need to shift across the x-axis. So 0, the value of y equals 0 remains, but the value of 1 will be a negative 1. The value of 2 becomes a negative 2, and the value of negative 1 becomes a positive 1. And here is our new function. One last example. If we were asked to solve log base 12 of x minus 3 equals the log base 12 of 2x plus 5, we recall that the log base a of x is equal to the log base a of y, means that x equals y. So in this case, x minus 3 will be equal to 2x plus 5. Now it's a simple matter of solving. And negative 8 is equal to x.